Good to meet you all once again here in Surpac Tutorials, and today's tutorial presents to us another exciting interaction with drill holes and ore deposit. In today's lesson, we are going to cover how to generate intersections between drill holes and a three-dimensional model, in this case the ODTM. The topography will also be used to cut off or truncate the part of the ore model which goes beyond the ground surface. So without wasting much time, let's get down to Surpac and see what we can do. Go to database, display drill holes. From no particular table, I'll click apply. Then I'll display my ore domain 1 DTM. Alright, so what is it that we want to do? We want to identify which part of the drill hole intersects the ore DTM. In other words, the interval along each drill hole that intersect the ore DTM. And how are we going to go about this? We will first create a table in our database, and this table that we will create will contain the intervals for each drill hole that intersect the ore envelope. So let's go ahead into the database and create a new table. Go to database, database again, come down here to administration and come down to select create table, click on it. And the form will appear. Here we have database name. New database is the name of our database, as you can see in the status area. It is also appearing inactive because you cannot change the name here. Table name. What name would you want to give to the table that you want to create? Because we are trying to come up with an analysis to determine which part of the drill holes intersect the ore DTM, I would opt to enter a name, say intersection. Okay, then table type. If you have watched the first lesson of my Surpac tutorial series, you will notice that I have explained all these things: interval, point, and discrete tables. Interval here has been selected because we are trying to come up with an interval along the drill holes that intersect with the ore DTM. That is why interval has been checked, and maintain that because we are going to create an interval table. Time dependent. You don't have to check the time dependent box because whatever table we are going to create is independent of time. I'll click apply to continue, and I'll be presented with the form for define all fields for all tables. Again, if you have watched the first lesson of my Surpac tutorials, I'm pretty sure you're familiar with this window. Here we have mandatory fields and we have optional fields. We are not going to do anything whatsoever to the mandatory fields. We will head down to the optional field and create a new field called ore zone. And the type of field is going to be a character field. You check the box for the null section, and the length you can enter any number to suit your preference. Let's say 20. Okay, and I'll click apply. And it says in the message window, create table processing completed, meaning our table has been completed, has been created. We would want to verify the newly created table in our database, and we can do this in so many ways. We can go to database, display drill holes. Now we will want to select the table that we want to display our drill holes for. I'll click on this, and if you have taken notice of this, anytime we wanted to display our drill holes from a particular table, we were presented with assay, color, and geology tables. We didn't have intersection, but now we just created an intersection table, and it has been added to the list of table names in our database. So I'll select this one. Then the field, you can select any field that you want to view, no constraint, apply. And the drill holes will be displayed, meaning our table has been created successfully. Beautiful. Another way to verify that the table has been created in our database is to go to database, come down here to report and select database summary. Click on it, and the database summary report window will appear. Here we have database name, which is the new database. Report file name, you can enter any name which will be the name that you would want to use to save the summary for your database if you want to have a file for your database summary, you can enter any name here, and the format you can select anyone to suit your preference. Alright, we have table name, data type, table type, and number of records. The table name refers to all the tables that we have in our database, and initially we created our database from assay, color, geology, stars, survey, and translation. We just added intersection tables. Type of data. Interval tables have been presented here because in our database we have assay, geology, and intersection tables. We just created an interval table as intersection. The table type, we did not check the box for the time dependent because our tables are not dependent on time. That is why we have presented here time independent. Then the number of records. 0 number of records is presented or shown here for the intersection table. This is because we have created the intersection table but we have not imported any data into it. That is why it is showing here a null record. Okay. Another way to determine that your table has been created in the database is to go to database, edit, view table, click on it, and this time we will select the table name intersection as is appearing here. Apply, and the window will appear. Table intersection. You can see that the fields have been created here but there is no data. That was why we were shown in the database summary that 0 number of records. This is the field that we created, all zone, and it's shown in the page number here 1 of 0, meaning we have no records here. Alright, after performing analysis to determine which part of the drill hole intersect our ODTM, this table will update itself with that record. Okay. So what next? We are going to come up with analysis to determine which intervals along the drill holes intersect our OR envelope. Go to database, analysis, and select drill hole 3DM intersection. Click on it. Apply. No query to be applied to the drill holes. And we are presented with this beautiful window. Here we have defined the object number to intersect with. The object number here refers to the object in graphics for your DTM. Remember, the number here refers to 8 because that is the number we gave to our object when we were creating the model. So we have here 8 as default. Name the layer for saving the resultant hole trace segment. After performing the operation, the analysis between the drill holes and the ODTM, the resultant of the operation will be displayed in graphics. We are recommended to enter a name for that particular layer, which will appear in the layers pane here, to save that resultant of the operation. So let's say I want to enter a name intersection to save that layer intersection. Okay, and here we have save intersections to database. Remember, we have created a new table called intersection in our database, and we want that table to save the intervals for the drill holes that intersected the OR envelope. So we are going to save whatever analysis or operation that we are going to perform here in our database. So this box has to be checked, and you will go into the database to select the table. This time we will select the intersection because we are going to save everything in the intersection table. Click on it, and the field name is going to be all zone as we created. And here, intersection code. The intersection code should be numeric. Please take note of this. It should be numeric so that the code is what is going to save the drill hole interval. It's going to serve as a specification. You can enter any number to suit your preference. If you enter a character field here, the operation is never going to be performed. Okay. Define the log file for the results. You can enter a name for the report that will be generated. Let's say drill hole and OR intersection. I'll enter that OR underscore drill hole intersect. and the format I would want it to be in a CSV format. Apply. As you can see, it says validation of field intersection code field. We will have to enter a number for the intersection code, and this field should be numeric. So you can enter any number of your preference. Let's say 3, or the object number, which is in graphics 8. Apply. And it says in the status area, processing drill holes, the operation is being done. So let's wait for a while. Okay, so we have here the report, all drill hole intersect. This is the name we gave to the report file. And we have here hole ID, depth from depth to. Remember, it's an interval table we created in the database. So we are going to have a field of depth from and depth to. And this is the code we gave to the intersection 8. Okay, as you can see here, for this particular hole ID, from 19.5 meters to 55.5 meters, the drill hole intersected an ore zone. Alright, the reason why we created this report is that a printout of this report can be generated and given to the field geologist or technician so that all zones for infill drill holes can be anticipated. For instance, with this printout, if a hole is drilled between hole number 1 and hole number 2, a geologist or technician can anticipate that mineralization is likely to occur. Let's say this is 19.5 and this is 21. We can say mineralization may be present from, let's say, 20 meters to 58 meters. That means a drill hole in between hole 1 and hole 2 may have mineralization occurring between, if you could interpolate these values, you can say 20 meters to 58 meters. This will call for proper scrutiny or proper inspection of drilling and sampling protocols when approaching that interval. Okay, so I'll close this report, and now we will save the layer. Remember, the layer name has appeared here, intersection. If I should hide all my drill holes, database display hide all drill holes, you can see that, and I'll display my transparency for the ore model. You can see that the drill holes, the part of the drill holes which intersected the ore, is left inside the ore, and that is the name we gave to the layer as intersection. So if I should hide that layer, you realize that the drill holes, the portion of the drill holes which intersected the ore model, has disappeared. If I should bring it back, it will be displayed. So go to save, let's say intersection, the same name as the layer, and it will be a string file. You can call this for future use. Apply. And if I should exit graphics and bring the layer intersection, this is it, the portion of the drill holes that intersected the ore model. Okay, so now let's go back to the table and view what we have there. Exit graphics, database, edit, view table, intersection, apply. Beautiful. Now we are presented with records. Initially we did not have any record in the table, but after performing the intersection of the drill holes and the ore DTM, we have been presented with 20 records. This is the intersection code 8, the depth from 19.5 to 55.5 meters as initially revealed from the report. So these are the intervals, depth from and depth to, along the drill hole trace that intersected the ore DTM. And the page number has been updated, page 1 out of 1. Okay, so we can go and check this from the database summary and see if the records have been updated. Okay, go to database report, database summary, click on it, and now as you can see, the number of records have been updated for the intersection table. Initially it was 0 and now it is 20. When we opened the table, we saw 20 number of records. Beautiful. Okay, our next task to be performed is to truncate the OR model with the tuple. If I should display my OR domain 1 DTM and the topography of the area, you realize that the OR domain extends beyond the tuple or goes beyond the ground surface. The reason why you are seeing this is because when we were digitizing the mineralization zones using the assays as guides, we digitized in such a way that our segments went beyond the drill hole colors. So if I should display the colors for the drill holes, you realize that we created the segments for the OR model beyond the tuple. That is why if you should create a DTM from the string file, obviously the DTM will also go beyond the colors of the drill hole. That is why you are seeing that here. We may interpret this as an outcrop of a mineral deposit, that is an exposure of the mineral deposit at the rock surface, but this condition is actually unrealistic. Hardly will you come across a mineral deposit highly exposed like this. So we should come up with a cleanup or a solution, and the recommended solution is to trim the OR deposit so that it becomes located beneath the tuple. So we will cut off this portion which is exposed here. So let's do that quickly. I will head over to the solids menu, click on it, come down here, select solid tools, and come here to select clip solid below a DTM, because we want to clip the OR model DTM beneath the tuple. So I will click on that. Okay, and here we are presented with this small window, graphics layer name. The resultant of the operation will be saved in graphics. That is after performing the intersection, the clipping of the DTM of the OR under the tuple. The resultant will be saved in the graphics. So we would want to give a name for that layer that will host the resultant. Let's give it a name, say OR domain 2. Then the object number. What number would you want to give to the OR model that will be created beneath the tuple? Let's say 2, which will be an object color of blue. Apply. And it says in the status area, select the 3DM trisolation. This is the solid OR model, so I will click on that. And it says again in the status area, select the DTM trisolation. I will click on the tuple because that is the DTM. And as you can see, the OR DTM has been truncated, or the upper part, the upper portion of the OR that went above the DTM has been cut off, and we are left with the remaining portion here. Okay, and as you can see, the OR domain 2, that is the layer name that will save or store the operation, the resultant of the operation is here. So we can save this layer name, go to save, and immediately I clicked on the save. The object number 2 has been updated here, which is blue. I will give it a name, OR domain 2. And this will be a DTM file. Apply. Alright, so if I should exit graphics and come back for my OR domain 2 DTM and my topography, you realize that the tuple is now beneath, the OR model is now beneath the tuple, and we can see traces of the OR model here. This actually seems realistic compared to the previous one. if I should display my drill holes from no particular table, apply. Now we are seeing the drill holes penetrating the OR model, and the OR model is right beneath or below the topography. Alright, so that is it for this tutorial. Catch you in the next lesson where we get to do compositing studies. Catch you later. Bye.